Okay, everybody, I am working on our review for our Chapter 2 test that is this week. And the first thing I want us to look at is number 1. It says label all the points in the given diagram with ordered pairs. The length between two consecutive notches on a particular axis is 1 unit. And what that means is when we are looking at that distance right there, we're talking about 1 unit. Okay, so anytime, so from here to here, we're talking about 1 unit. That's what that means. It's not measured by 5 or 10 or anything like that. The unit is 1. So I'm going to start with P. And for this, we go over 1. And we're working on negatives. So that's going to be negative there. So negative, we go to -1, and we always deal with our x-axis first. And then we go up to +5. So we've got -1, +5 for our point P. So I'm going to write that right here. Point P is -1, +5. And again, you always do your x value. Your right to left always goes first. Okay? For our next value that we're going to do is Q. So for this one, we are going over 4 units, and then we are going up 3 units. So the value for Q, or the ordered pair for Q, is 4, 3. Okay. Next, we are going to do R. R is on the x-axis, and so we go over 2, and we are going up 0. So our ordered pair here is 2, 0, and that is on the x-axis. And then our last point is S, and we are going over -3, because we're going to the left, that's negative, and then we are going down -3. And because we are going down, that is also negative. So this ordered pair is -3, -3. And what I want you to keep in mind is we always deal with our x-axis first. So our ordered pairs are always x, y. Okay? Now, for number 2, we are drawing an ordered pair, or we're drawing an x and y axis, and then we are plotting these ordered pairs. And so let's draw an y-axis and an x-axis. And we're going to put arrows on each of the end of these. And we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. -1, -2, -3, -4, and -5. So the first point that we are going to do is -2. So we will go from the origin 2 to the left because it's negative. And then we will go up 3. So 1, 2, 3. So this point goes right here, and this is point -2, 3. Okay? The next point that we're going to do is 4, 0. So this point's going to be on the x-axis. So we are going to go 1, 2, 3, 4, and we're going to go up 0. So that is our point, and the ordered pair is 4, 0. The next point is -1.5, +2.5. -1.5, +2.5. So we are going to go to the left 1.5 spaces. And we're going to the left because it's negative. Then we are going to go up 2.5 spaces. Okay, and so it's going to be kind of close to that -2, 3, but not quite. So we go -1.5 over, +2.5 up. And so here I've got -1.5. Whoops. Let me try that again. Do the point. About right here is our point. And I'm going to kind of draw it like that. So then we're going to have negative 1.5, comma 2.5. Okay, the last one is 5, so that's going to be going to the right. Then we are going negative 3 over 2. Negative 3 over 2 is negative 1.5, and so our point is going to be about right here. Okay, so that point is positive 5, negative 3 over 2. Okay, our next question is asking us to find the distance between these 2 points, and our points are 7, 10. So our x-axis is, or our x-coordinate is 7, our y-coordinate is 10, and the other point is 4, 8. So I'm going to do x sub 1, y sub 1, and I'm going to do x sub 2, y sub 2. And it doesn't matter which point you identify as x sub 1 and y sub 1, and which point you identify as x sub 2 or y sub 2. The big thing that you've got to remember is whichever point you start with as x sub 1, you've got to have that corresponding y value. Now, if you remember, the distance formula is very much like the Pythagorean theorem. So what we're going to do is we're going to take we're going to find the difference between our two x's. So I'm going to say 7 minus 4, and then we are going to square that. Then I am going to add that to 10 minus 8, and then I'm going to square that. Then I'm going to take the square root of all of that after I've simplified that out. So 7 minus 4 is 3, and I still have to square that. And I am adding that to 10 minus 8. 10 minus 8 is 2, and I'm going to square that. Okay, so 3 squared is 9. I am going to add that to 2 squared, which is 4. 9 plus 4 is 13, and that is the square root of 13. Now, I don't want you to take an approximation of that, okay? Square root of 13, we're going to leave it as the square root of 13. The approximation of square root of 13 is a non-repeating and a non-terminating decimal. So it's more accurate for us to leave it as the square root of 13. Now, we're also going to find the midpoint with these two. So in order to find the midpoint, I am going to take my x values and I'm going to add them together and divide by 2. And then I'm going to take my y values, add them together, and divide by 2. So I have 7 plus 4, that is 11 over 2. Then I have 10 plus 8, which is 18, and that is over 2. And I wrote a 9 right there because my brain kind of got ahead of me, but that should be 10 plus 8 over 2. And 18 divided by 2 is 9. So that's where that came from. 11 over 2, that is in simplest form. So we're going to leave it like that. 18 over 2 does simplify to 9. So 11 over 2, comma 9, that is our midpoint. Okay? Now, for this problem, the directions say, check each given ordered pair to see if it lies on the graph. 2x squared minus 4y to the third equals 12. Now, we're not graphing that. We could graph that in Desmos if we wanted to, but that's not what we're doing right now. What we're doing is we're going to take the 3, and we're going to plug the 3 in for x, and then we're going to take the 2, and we're going to plug the 2 in for y. And we're going to check each one of these points. So I have 2, 3 squared. Okay, and actually I want to rewrite that because the squared goes outside the parentheses. And I know that that seems that there's no difference, but there actually is a difference. And so I want to write that correctly. If where I had written the 2 inside the parentheses here, if my 3 had been negative and I had the 2 written inside the parentheses, that would mean my negative wasn't being squared. But the way that I have it written with the 2 outside the parentheses, if that 3 is negative, the negative and the 3 is being squared. So it is important that it get written like I have it highlighted here. And that will be an issue on our third example here. So now what I've got is I have 2 times 3 to the second power. So I'm going to go ahead and do 3 squared, which is 9. Then I have 2 to the third power, and that is 8. Okay, 2 times 9 is 18. 4 times 8 is 32. Okay, and so we can tell at this point 18 minus 32 is going to be negative 14. And that is not the same thing as 12. So the answer to this is no. And what the no means is that the point 3, 2 does not fall on this graph. 2x squared minus 4y to the third equals 12. That's what that means. So now we're going to do 2, negative 1. Okay, so I am going to have 2 times 2 squared minus 4 times negative 1 to the third power equals 12. We have to do our exponents first. So we have 2 to the second power. Okay, 2 to the second power is 4. Now I'm going to do negative 1 to the third power. And we talked some in class that if you take a negative and you raise that to an odd exponent, it's going to stay negative. So negative 1 times negative 1 times negative 1, that's negative 1 to the third power, and it stays negative 1. Okay? So now we have 2 times 4 is 8. Negative 4 and negative 1, that is positive 4. And in this situation, I get 12 equals 12. And so this is a yes. And what that yes means is that this point 2, negative 1 is on the graph of 2x squared minus 4y to the third equals 12. Okay? Now my last one is negative square root of 2, 2/3. So I'm going to move down just a little bit so that we've got plenty of room here. So I've got, and I'll do it in a different color just so we can make sure we can tell the difference here. Okay? So I have 2, then I have negative square root of 2 squared minus 4 times 2 over 3 to the third power equals 12. Okay, I'm going to deal with my exponents first. So this negative square root of 2, because that negative is on the outside, we are not talking about something imaginary. Think of that as a negative 1. So we are essentially taking negative 1 and squaring it. So that's going to give us a positive. Then we are taking the square root of 2 and squaring the square root of 2. That also gives us 2. Now, we have a fraction here. So I'm going to do 2/3 to the third. And we talked about our properties of exponents in 131. If you don't remember that this 3 belongs to the 2 and the 3. So this is 2 raised to the third power and 3 raised to the third power. So 2/3 to the third power is the same thing as 8 over 27. And that equals 12. So now we have 4 minus 4 times 8, which is 32. That's 4 over 1 times 8 over 27. So we have minus 32 over 27 equals 12. At this point, if you think about it logically, you could stop. 32 over 27 is just over 1. So I have 4 minus a number that's a little bit over 1. That is not going to equal 12. So it's pretty safe to say, no, this doesn't simplify out. Now you could do 27 times 4. Okay, so 27 times 4 is 108. So we could have 108 over 27 minus 32 over 27. And we would get 76 over 27, and that doesn't equal 12. So it's pretty safe to say that negative square root of 2, 2/3 is not on this graph either. Okay? Now, for number 5, we're working on x and y intercepts. Now, by definition, to find our x-intercept, we plug 0 in for our y value. Okay. To find our y-intercept, we are going to plug 0 in for our x value. Okay, so our first one right here, we have y equals x to the third minus 6x squared minus 27x. So we're going to find our x-intercept first. So I'm going to write x-intercept. So what I'm doing here is I'm going to plug 0 in for y. And I have x to the third minus 6x squared minus 27x. So I'm going to go ahead and solve that. Okay, so first thing I'm going to do is I'm going to factor it. I'm able to see that there is an x in each of the terms. So I'm going to factor out an x first. So I'm going to have x times x squared minus 6x minus 27. Okay. Now, my next step is to look at my product and look at my sum. So my product is negative 27 and my sum is negative 6. So I need two numbers multiplied together that give me negative 27 and added together give me negative 6. And those two numbers are x minus 9 and x plus 3. Because positive 3 and negative 9 give me negative 6 when I add them together, and they give me negative 27 when I multiply them. So now I'm going to set each one of these factors equal to 0. So my x-intercepts are 0, 9, and negative 3. Okay? So we could write those as ordered pairs. They'd be 0, 0, 9, 0, and negative 3, 0. Okay? Now I'm going to do my y-intercept. So for my y-intercept, I am going to plug 0 in for all of my x's. So I have y equals 0 to the third minus 6 times 0 squared minus 27 times 0. And when I do that, I end up with y equals 0. So my ordered pair for my y-intercept is 0, 0. So here are my answers. Here are my x-intercepts right here. And here is my y-intercept. Okay. For our next problem, we'll go ahead and start with our x-intercepts. So when we're doing our x-intercepts, we plug 0 in for y. So I have 4x minus 0 squared equals negative 25. Okay, 0 squared is 0, so I'm left with 4x equals negative 25. Divide both sides by 4, and I'm left with x equals negative 25 over 4. Now, if I write that as an ordered pair, that's my x value. Negative 25 over 4, and 0 is my y value. So that is my x-intercepts. Now, I'm going to go ahead and erase this part of the screen just because I'm running out of room. So let's erase that, and then we're going to do our y-intercepts for our second. So this is y-intercept for this problem. Okay, so now for my y-intercept, I'm going to plug 0 in for x. So I have 4 times 0 minus y squared equals negative 25. Okay, 4 times 0 is 0. So I can just mark that out. Then I'm left with negative 1 y squared. Now, one of the things that we do is very often we drop our negative that belongs to that y squared. So be sure that you don't do that. And then I am dividing by -1. So I have y squared equals 25. Now, if I take the square root of both of these, the square root of y squared is y, and the most common remembered square root of 25 is 5. But 5 squared does equal 25, but I want to remind you that -5 squared also equals 25. So when you take the square root of both sides, don't forget about your positive and your negative, okay? So 5 times 5 is 25, and -5 times -5 is 25. So our y-intercept is both 5 and -5, okay? This is a parabola that's kind of on its side. It's on its side compared to the U shape that we see when x is squared. So our y-intercepts here are going to be 0, +5. That's our y-intercept. And our other y-intercept is going to be 0, -5. Okay? So our x-intercepts for this one is -25/4, comma 0. And our y-intercepts are 0, 5, and 0, -5. Okay? Now, number 6. This is one that students struggle with quite a bit. So let's talk through what actually happens when we're talking about the symmetry of an equation or the symmetry of a graph. So there's 3 symmetries that we look at. The symmetries are, is it symmetrical to the x-axis? Whoops. Okay. So we ask ourselves, is this symmetrical to the x-axis? Is this symmetrical to the y-axis? And is this symmetrical to the origin? Okay, so these are the things that we are asking ourselves about this specific equation. X equals 3y squared minus 5. Okay? To determine if something is symmetrical across the x-axis, we replace y with -y. Okay, so here I have my original problem. X equals 3y squared minus 5. So what I'm going to do is I'm going to take out that y, and I'm going to put in -y. Okay, so I've just taken out the y and I've put in a -y. It's still going to be squared, and I'm still subtracting 5. So I have to deal with this -y squared first before I can deal with anything else. So -1, the negative and the y is being squared. So a negative squared is going to give me positive, and that's going to be positive y squared. Okay, so what I did here is I took out my y and I put in a -y. Then I simplified it. And because I got exactly the same thing here that I have here, that means that this is symmetrical across the x-axis. So if we graphed this and we folded the x-axis, then the two parts of the graph would be on top of each other. So this particular function right here, or this isn't a function, this particular graph, an equation right here, is symmetrical to the x-axis. So the answer to this is yes. Now, I want us to talk about how we check for symmetry across the y-axis and the origin. To test if something's symmetrical across the y-axis, we are going to replace x with -x. Okay, so here's my original problem. X equals 3y squared minus 5. So I am going to take out my x, and I am going to replace that with -x. Okay, then I'm keeping everything else the same. 3y squared minus 5. So I'm going to simplify this to c. So the way that I simplify this is I'm going to divide everything by -1. So then I have x equals -3y squared plus 5. I could move it around a little bit more if I wanted to, but it's really not necessary because this right here is different than what I had in my original, which is right here. So because of that, this is not symmetrical. So the answer to this is no, it is not symmetrical across the y-axis. For our last one, to see if something's symmetrical across the origin, we are going to replace x with negative x and y with negative y. Okay, so here's my original. I have x equals 3y squared minus 5. So I am replacing x with negative x, and I am replacing y with negative y. So we're going to simplify as much as we can. So I'm going to deal with my negative y first, because in the order of operations, we have to deal with exponents early. So I have negative 1y squared. The negative and the y is being squared. So that is going to make it positive y squared. So I have negative x equals 3y squared. Just like when we were testing for symmetry across the y-axis, I'm going to divide everything by negative 1, and I end up with x equals negative 3y squared plus 5. Okay? This equation that we get right here is not the same as what we started with. Therefore, this is not symmetrical to the origin. So the answer to number 6 is that this is only symmetrical to the x-axis. The only symmetry that we find with this is to the x-axis. Okay? Now we're going to move on to number 7. Number 7 wants us to state the center and the radius of the circle. The positives and the negatives typically mess students up with circles. So remember, the formula for a circle is x minus h squared plus y minus k squared equals r squared. So pay attention right here, because your h and your k values are opposite of what you see in the binomial. So in this one right here, I have x minus 6 squared. So in the formula, we have x minus h. So our h value is the 6. It's not negative 6, it's just the 6. So the h value for this circle is the 6. Now look here, we have y plus 14. Our formula for a circle is y minus k. So we have to take the opposite of what we see in this y plus 14. So our k value is negative 14, and that very often confuses students. So be very, very careful with that. Okay, so that is the center of our circle, 6, negative 14. Now, remember, in our formula, our radius is squared. Radius is squared. So when I, in my formula, have x minus 6 squared plus y plus 14 squared equals 17, we have to remember that that 17 is my radius squared. So in order to get the radius of this, we have to take the square root of that 17. So the center of our circle is 6, negative 14, and the radius is the square root of 17. Okay? Now for our next one, we are given the center and we're given the radius. So we are going to look at our formula, which is x minus h squared plus y minus k squared equals radius squared. Okay, so we're going to plug in our negative 7 and our 4/5. So we are going to have x minus negative 7, and we are going to square that. Then we are going to have y minus 4/5 squared equals 6 squared. Okay, So the first thing we're going to address is this double negative right there. So I'm going to end up with x plus 7 squared. Okay, our y values, we're just going to leave it the same. Y minus 4/5 squared. And then finally, we're going to square our 6, which is the length of our radius. So 6 squared is 36. Okay. Now we are going to move into some linear problems. So for this one right here, this is number 9, we are putting in, let me read the directions exactly. The directions say, write an equation in slope-intercept form for the line with the given properties. Okay, so for this line that we're doing first, we have a slope of 2/3 and we have a y-intercept of 0, -1. So we already have our y-intercept, so we don't have to figure that out. We have a slope of 2/3 and our y-intercept is -1. So when we put this in y equals mx plus b, okay, we're left with y equals 2/3 x minus 1. Okay, and we are going to graph that. Okay, and our first point that we are going to use starts at our y-intercept. So that is right here at -1. Okay. Then we are going to go up 2. So I'm going to do this with a highlighter. So I go up 2, then I go over 3. 1, 2, 3. So that is another point on our line. Now we could continue to go up 2 and over 3 as many times as we wanted to. And there is our line, right there. Okay. Okay. For this particular problem, we are going to have to use the point slope form of a line, and that is y minus y sub 1 equals m times x minus x sub 1. And m is your slope, and x sub 1, y sub 1 is any point on the line. Okay, it's any point on a line. So I am told that my slope is 2, and I'm told that my line passes through the point 1, 3. So I'm going to have y minus 3 equals 2 times x minus 1. Okay, now I have to graph this, so I need to have it in y equals mx plus b format. So the first thing I'm going to do is distribute my 2. So I have y minus 3 equals 2x minus 2. Then I'm going to add 3 to both sides. So I have y equals 2x plus 1. Y equals 2x plus 1. And we need to graph that. So I'm going to do my x and my y axis. That's actually my y axis. Now I'll do my x axis. Okay. Okay, and I have 1, 2, 3, 4. Okay. Let's see if I can do the line in a different color this time. Okay, so I'm going to start at +1 because that's my y-intercept. And then my slope is 2. So I'm going to highlight it. So I'm going to go up 2 and over 1. Okay. Now, I could go down 2 and over 1. That's also okay because down 2 is -2 and to the left 1 is -1. So that makes it a negative over a negative, which is a positive. So now, and this is definitely not perfect, but that is my line. Okay. Okay, our next line has a slope of 0. And remember, when we're talking about a slope of 0, that means that there's no change. We talked some about having money in the stock market. That means that you're not losing money, but you're also not making money. Also, if we're talking about weight, that means you're not gaining weight and you're not losing weight. It is a constant. That's when you have a slope of 0. Okay? So we need to kind of think about what this means. So there's my x and my y axis. Okay, so it doesn't matter. So I'm going to put my positive 1 and negative 1. So positive 1 and positive 2. Positive 2/3 hits about right here on my intercept. So it doesn't matter what our x values are. All of our y values are 2/3. And so that is what my line looks like. And when my slope is 0, it's always a horizontal line, and it's always y equals 2/3. And this means there is no change. And it's okay to have no change. When you do your slope, it may look something like 0/4. And it's okay to have a 0 in the numerator. What's not okay is 0 in the denominator. And that's what our next one is talking about. We have an undefined slope. An undefined slope is when time stops. Okay? Undefined slope is when time stops. So in this situation right here, we are talking about a vertical line. A vertical line. And here's my x and y axis. Okay. And the point passes through over 4 and up 2. So our point passes through this point right here. Over 4 and up 2. And it's vertical. And the reason that we know that is because it tells us that our slope is undefined. So anytime we have a slope that's undefined, that's like having 4/0. It's the 0 in the denominator that makes it undefined. And if we're thinking about the stock market or we're thinking about weight loss, we are talking about when time stops. And we know that time can't stop. And so that is when we have a vertical line. And the equation for a vertical line are our x values. And so all of these are x equals 4. And that's a vertical line. Okay, for number 10, it says, put the equation 6x minus 2y equals 3 into slope-intercept form, then identify the slope in the y-intercept. So we have got to solve for y. That's what we are doing. Now, 6x minus 2y equals 3 is in standard form. We don't use standard form a ton for linear equations. When we talk about quadratics and when we talk about polynomials, we do use standard form quite a bit. But in linear stuff, it's just not that helpful. But the way that we get it from standard form to slope-intercept form is we solve for y. So the first thing I'm going to do is I'm going to subtract 6x from both sides. Okay. Now the danger here is dropping this negative. Okay. Do you see that negative 2y? All the time students drop the negative. So keep that negative with that 2y. Then I have negative 2y equals negative 6x plus 3. My next step is to divide by negative 2. So then I'm left with y equals negative 6 over negative 2 is positive 3. Negative over negative is positive. Then I'm left with minus 3 over 2. So my slope for this, for number 10, is 3. And my y-intercept, or my b value, is negative 3 over 2. And if I were writing that as an ordered pair, I would write that as 0, negative 3 over 2. That's how that is. And I don't think it's asking us to graph it. It is not. Now, number 11 wants us to take the 2 points, -2, 6, and 8, 12, and we're going to go all the way to putting that into y equals mx plus b. But the first thing we're going to do is we've got to find the slope. Okay, so I am going to do change in y over change in x. So I've got 12 minus 6. And do you see how I started with the 12 here for this problem? I have to start with the 8 for my x. So now I'm going to do 8 minus 6. So 12 minus, whoops, nope, there we go. Okay, I made a mistake. So I have 12 minus 6 for my change in y's. Then for my change in x's, I've got 8 minus -2. So I've got 8 minus -2. 8 minus -2 becomes plus. Okay, we had a double negative there. So 12 minus 6 is going to be 6. 8 plus 2 is going to be 10. So my slope is going to be 3 over 5. Okay, now the next thing that I want to do is I want to take this slope and I want to take either point. It doesn't matter which point you take, and put it in point slope form of the line. So I'm going to use this point right here, -2, 6. But if you used 8, 12, you would be completely fine. Okay, so I would do y minus 6 equals 3/5 times x minus -2. So our minus -2 becomes plus 2. So I've got y minus 6 equals 3/5 x. And then I have 3/5 times 2 over 1. So y minus 6 equals 3/5 x plus 6 over 5. Okay, now I'm going to have to rewrite this. Because I need to add 6 to both sides. So I have y minus 6 equals 3/5 x plus 6 over 5. So now I'm going to add 6 to both sides. And I'm adding 6 over 1. So this part right here can get confusing for students. So I'm going to write that in a different color. I'm going to write that in green, kind of above us, so you can see exactly what's happening. I have 6 over 5, and I am adding that to 6 over 1. And because I'm adding fractions, I have to have a common denominator, and that common denominator is 5. So I'm going to rewrite this as 6 over 5, and then something over 5. So I ask myself, how many times does 1 go into 5? The answer to that is 5 times. And then I multiply 6 times 5 to get my numerator. And so that is 30. So if you ask yourself, what is 30 divided by 5? You will get 6. So 6 over 1 and 30 over 5 are equivalent fractions. And when we add those two together, we get 36 over 5. So my final answer here is y equals 3/5 x plus 36 over 5. Okay. Now, let's move on to number 12. So number 12, we have an x and y. Both my x and my y is raised to the first power. So we are talking about something that's linear. And the directions to number 12 say, consider the line 3y plus 9x, that whole quantity over 4, equals 5. So the first thing that we're going to do is we're going to put that in y equals mx plus b format because we really can't do much with this right here. So the first thing that I'm going to do here is I'm going to multiply by 4 over 1. Okay, so I'm multiplying by 4 over 1. So now I'm left with 3y plus 9x equals 20. And hopefully that looks a little bit more manageable for you. Now this is in standard form, so we're going to go ahead and solve for y. So I'm going to subtract 9x from both sides. And you've got 3y equals negative 9x plus 20. Divide both sides by 3. And I get y equals negative 3x plus 20 over 3. Now this is our original line. Our original line is y equals negative 3x plus 20 over 3. The only thing that we care about from our original line is the slope. So we've identified our slope from our original line as negative 3. Now, for all lines that are parallel to this original line, they have to have the same slope. So our slope for all parallel lines is going to be negative 3. Now, perpendicular slopes are negative reciprocals. Negative reciprocals. And so what that means is we take our negative 3, we make it its opposite sign. So instead of having negative 3, we're going to have positive. Okay? Then we are going to flip the fraction. So I have positive, and then I have 1/3. So the slope of all my perpendicular lines is going to be positive 1/3. So perpendicular lines have negative reciprocals of the original line. Parallel lines have the same slope. They are the identical slope. Okay? So let's move on to number 13. So for number 13, we are given a function. The function is f of x equals 4x squared minus 3x plus 1. And we are being asked to find several values for x in here. So the first one that I have is negative 3, f of negative 3. So what I'm going to do is I'm going to take this negative 3 and I'm going to plug it in where there is an x. So I'm going to have 4. Okay. And then I'm going to have my negative 3. Going to go right in there where the x was. So I'm going to have negative 3 squared. Then I'm going to have minus 3. Put my negative 3 in there as well. Okay, so I have 4x squared minus 3x plus 1. And so now I have 4 times negative 3 squared minus 3 times negative 3 plus 1. So I have to do my exponents first. So negative 3 squared is 9. And again, I just want you to look at what is being raised to the second power. The negative and the 3 is being raised to the second power. So be careful and make sure you're aware of that. So I have 4 times 9. Then I have negative 3 times negative 3, which is also positive 9, plus 1. 4 times 9 is 36. Okay, plus 9 plus 1. 36 plus 9 is 45, plus 1 more is 46. So f of negative 3, that's when we took negative 3 and plugged it in for my x's, I ended up with 46. Now, for our next one, we're going to plug in 1/2. And I would encourage you not to turn that into a decimal. I know that fractions make us nervous, but it's better to not turn that into a decimal. So I'm going to have 4 times 1/2. And then I am going to square that. Minus 3 times 1/2 plus 1. Okay, so I've got to deal with my squares, my exponents first. So I have 1/2 raised to the second power. That becomes 1/4. Then I've got negative 3 times 1/2, so that's going to be 3/2 plus 1. Now, 4/1 and 1/4, that simplifies to 1. So that is actually super helpful. Okay? Now, I have a positive 1 and another positive 1. So I can go ahead and add those together, and then I am subtracting 3/2. So we're dealing with like common denominators. So my 2/1 is going to become 4/2. 4/2 minus 3/2, and my answer here is 1/2. So f of 1/2 actually is 1/2. Okay? So I am going to take f of 0, and I'm going to kind of move it over to the side right here. I didn't quite have enough room. So for this one, I'm plugging in 0 for any time I see an x. So I have 4 times 0 squared minus 3 times 0 plus 1. 0 squared is 0, so then I have 4 times 0 minus 3 times 0 plus 1. 4 times 0 is 0, minus 0 plus 1, so my final answer there is positive 1. Okay. Now I need to erase all of this so that we can do f of 2x minus 1. So I'm going to erase my whole screen. And we're just going to leave the f of 2x minus 1. This is helpful when we do difference quotient. Being able to do binomials. So I'm going to write this the same way that I've been writing it so you can see exactly what's being plugged in for the x squared, or for the x. So I have 4 times 2x minus 1, and that 2x minus 1 is being raised to the second power. Then I have minus 3, whoops, okay, then I have minus 3, and I'm going to put 2x minus 1 there as also. Okay, and then I've got my plus 1. There's a couple of different things going on here. The first thing, before you can do anything else, is you've got to go ahead and square that 2x minus 1. And 2x minus 1 squared is the same thing as 2x minus 1 times 2x minus 1, and you have to FOIL that. So be super careful with that, because you don't just square the 2x and square the negative 1. You've got to FOIL this because you are subtracting. So 2x times 2x is 4x squared. 2x times negative 1 is 2x, negative 2x. Negative 1 times 2x is negative 2x. Negative 1 times negative 1 is positive 1. So 4x squared minus 4x plus 1. And as we get into factoring, you'll notice that this is a perfect square trinomial. And you don't have to be able to identify that, but sometimes it's helpful when you're factoring to know that's a perfect square trinomial. Now that we've figured out what 2x minus 1 squared is, I'm going to put it back because we've got to distribute that 4 now. So it's always good to do those when you're squaring a binomial off to the side. Here's my 2x minus 1. So now in the next step, this is where we're going to distribute. And we're going to have to distribute twice here. We're distributing the 4 to our trinomial. We're distributing the negative 3 to our binomial. So I have 4 times 4x squared. That is 16x squared. 4 times negative 4 is negative 16. And then we have our x. 4 times positive 1 is 4. Negative 3 times 2x is negative 6x. Negative 3 times negative 1, that's going to be positive 3. And then we're left with plus 1. Now our final step is to combine like terms. So the first thing I've got is 16x squared. I don't have anything else with an x squared. So I'm going to leave this as 16x squared. Then my next one, I've got negative 16x and negative 6x. When I add those two together, I get negative 22x. And then my last step, I have positive 4, positive 3, and positive 1. And that gives me positive 8. Okay, so f of 2x minus 1 is 16x squared minus 22x plus 8. Okay, let's move on to number 14. Okay, number 14 is a piecewise function. And what a piecewise function does is it tells us when to use which function. So we've got g of x equals 3x plus 8 when x is less than or equal to 4. And then we've got the square root of x plus 10 when x is greater than 4. So we have to determine, based on what input we are putting into this function, determines which one of the two rules that we use. So for the first one, we've got g of 4. So because this function, the 3x plus 4, says x is less than or equal to 4, that means that we're going to use this one because it says or equal to. So I've got 3 times 4 plus 8. 3 times 4 is 12, plus 8 is 20. So g of 4 is 20. Now, for g of 6, we are going to use the second function, the second rule, the square root of x plus 10. Okay, so I'm going to plug 6 into that x. So I have the square root of 6 plus 10, which is the square root of 16, and the square root of 16 is 4. So for g of 6, we use the lower function because 6 is greater than 4. Now we've got 10 over 3. 10 over 3. So we've got to decide, where does 10 over 3 fall? 9 over 3 would be 3. So that would be less than or equal to 4. 10 over 3 is 3 1/3. So that's still less than or equal to 4. So we're going to use that top function. We're going to use this one for 10 over 3. So I've got 3 times 10 over 3 plus 8. Okay, 3 is the same thing as 3 over 1. The 3's simplify out, and I'm left with 10 plus 8. Okay, so that is 18. So for g of 10 over 3, we use our top piecewise of our function, and we get 18. Now, for our last one, g of 10, we've got a number greater than 4, so we're going to use our bottom function, which is the square root of x plus 10. So I'm going to put 10 plus 10. Now, don't be tempted to multiply because we're not being asked to multiply here. We are adding. And we get the square root of 20. Now, if you leave it the square root of 20, you're okay. But I want to remind you that the square root of 20 simplifies to the square root of 4 times 5. And we can take the square root of 4. The square root of 4 is 2. So really, the square root of 20 in its simplest form is 2 on the square root of 5. And I would prefer that you leave it as 2 on the square root of 5. I don't want you going any further than that. Okay? Okay, on number 15, we're talking about domain. And remember, when you are talking about domain, we have to limit our domain in two situations. The two situations where we limit our domain is when we have a variable in the denominator of a fraction, and that's what's going on in our first example. Okay, because our denominator cannot equal 0. The other time that we limit our domain is when we have a variable in a square root. So those are the two most common times that at this level in mathematics, we limit our domain. So I'm going to put variable in square root. Okay, so in our first one, f of x equals 5x minus 7 over 144 minus x squared. We don't care about the top. The only thing that matters is our denominator. So I'm going to take 144 minus x squared equals 0 because it can't be 0. So we've got to figure out for what values does x equals 0. So now we're going to solve. I'm going to subtract 144 from both sides. Okay, I'm left with negative x squared. Don't lose that negative. That's something that we forget quite a bit. Then we're going to divide by negative 1. And I've got x squared equals 144. And 12 times 12 is 144. But don't forget, negative 12 times negative 12 is also 144. So our x cannot be 12, and our x cannot be negative 12. Okay? You could also have rewritten this, and you could have gotten x squared minus 144, and you could have used the difference of perfect squares to factor that. So if you ended up doing that, you were correct in that way. If you don't know what I'm talking about, then you probably didn't do it that way, and that's okay. We'll talk more about that when we do function or lots of factoring next semester or next unit. Sorry, I'm not thinking straight right now. Okay, so I am drawing positive 12 and negative 12 on my number line. So I am putting a big orange dot at negative 12 and positive 12 because I can't have my number be 12 or negative 12. If x is 12 or negative 12, I get a 0 in the denominator, and that's not allowed. I've got to write this in interval notation. So I'm going to start all the way down here. This is where I'm starting. And the value that happens all the way down here is negative infinity. So I have negative infinity, and I go all the way to negative 12. Okay? Then I have union, and I've got to think about the numbers in between negative 12 and 12. So I've got negative 12. Sorry about that. Then I've got negative 12 to positive 12. Okay? Then my last section is going to be anything greater than 12. And that goes all the way to infinity. So that is the interval notation for x cannot be 12 and cannot be negative 12. So when you have a variable in the denominator, that is when you focus on not having what's in the denominator equal 0. It can be negative numbers and it can be positive numbers, but what's in the denominator cannot be exactly 0. Now we're going to move over to the other one, and I'm going to have to erase this because I've run out of room, where I have a variable inside the square root. For inside the square root, you have to have a positive number inside the square root. Okay? It doesn't mean that x has to be positive. What it means is that what's inside the square root has to be positive. It can't be negative. It can be 0. So here I've got x plus 35 inside the square root. So what I'm going to do is I'm going to take x plus 35, and I'm going to set that greater than or equal to 0. When I solve that, I get x can be greater than or equal to to negative 35. So when I draw that number line, I have a 0. Here's my negative 35. Okay, it can be, so I'm going to color that in. It can be negative 35. So when I write this in interval notation, I use brackets, because remember, we can take the square root of 0. The square root of 0 is 0, so that's okay. So I'm left with negative 35 to infinity. Okay, we always use parentheses on infinity because it is a concept. It's not a number that we can actually reach. It is a concept. Okay, so students often will get the two mixed up. But when it's a denominator, you can't have 0. It's okay to have negative numbers in the denominator. It's okay to have positive numbers in the denominator. When it's inside the square root, that has to be greater than or equal to 0. So what's inside the square root has to simplify to that. So you're going to set that expression greater than or equal to 0. That's when we limit our domain. Okay? Now, for this one, we are going to identify the increasing, decreasing, and constant. So if we were to identify the range for this one, we would be talking about all real numbers. It would be negative infinity to infinity, all real numbers. But we're not dealing with domain. We're asking for increasing and decreasing. A couple of things that I want to point out. Right here, we've got the point -1, -1. This point right here is 2, -1. And this point right here is 3, 0. Now, when you are faced with a graph like this, it is always a good idea to write down those points, the points where you see a change in direction. If you do that, then you're able to focus more on these x values. So part 1 of this question says, talk about where it's increasing, talk about where it's decreasing, and talk about where it's constant. So our increasing, it looks like we've only got a very small portion where it's increasing, and it's right here. We are only looking at the x values. So we're only looking at the 2, and we're looking at the 3. That's where it's increasing. So it's increasing 2, 3. Okay? Now, we're decreasing in a couple of spaces. So let me go ahead and erase this yellow so that we don't get it all mixed up. Okay? So we